Our project focuses on automating lung cancer detection using CT scan images. We build a pipeline that extracts meaningful features from the scans, which are later used to classify cancerous and non-cancerous nodules. In this section, we extracted lung nodule features using three methods: Ia&Cd, pyridiomics, and a CNN model, each capturing different types of information from CT scans. With Ia&Cd, we loop through each patient's scan to compute semantic features rated by radiologists, things like texture, sphericity, and malignancy. These are then saved into a CSV containing over 2,000 annotated nodules. Next, pyridiomics extracts quantitative radiomic descriptors directly from the images, such as voxel intensity and shape complexity, giving a deeper numeric representation of each nodule. Finally, we use the pre-trained VGG16 CNN to extract deep visual features. Each 3D lung nodule is converted into three 2D slices, resized, and passed through the CNN to generate compact 512-dimensional feature vectors. All extracted features are stored in this CSV file, creating a unified dataset ready for machine learning models in the next stage.
For the data analysis, we're going to use the tools provided by the Ia&Cd library to perform a case-by-case inspection on the patient data. This is a visualization of a scan, telling us the number of nodules, number of annotations, and the location of the nodule. And here we have the nodule indicated by the red outline and the information of the nodule. We also have a 3D mapping to have a better understanding of the nodule's form. And this is the multiple annotations made by different radiologists, and the black dotted line indicates their consensus. For data cleaning, we've decided to remove malignancy rating equals 3 as there are no consensus, which to better divide the benign and malignant cases, we've told the model to consider ratings between 1 to 2 to be benign and 4 to 5 to be malignant. And down here we also have the class distribution, which is important to understand that there are only 30% that are malignant cases, which means the model is more prominent to predict false negatives. And false negatives in this context indicates that a patient who has cancer is not getting the right treatment. And down here we also have a brief explanation of the features of each dataset.
So this is the model training section. First, we import all the necessary libraries for data handling, metrics visualization, and model libraries. Then we define our training function. It splits the data, trains the model, makes predictions. The hyperparameters you see here were turned based on the previous tests for good balance between performance and computation time. At the end, it returns key metrics like accuracy, precision, recall, and F1 score. Next, we load our datasets for CNN features. Here, we train several models, and this block shows the confusion matrix, which compares predicted and actual classes. The diagonal shows correct predictions, while false negatives, which are critical in medical diagnosis, appear off the diagonal. We repeat the same process for random forest, SVM, and XGBoost. Then again for radiomics features and for pilots features. Before moving to the comparison part.
So for 7.7, we compared individual feature sets. We created this table with the different types of features in every model. The best one was random forest for radiomic features. And then we decided to fuse the data sets we created. So here we have a more robust and richer data set with the three types of extraction that we did before. And then we trained this data set. We created a confusion matrix for the same models that we tried before. So we have a baseline to compare. And here are the results. So finally, comparing our best individual results with the fused one, we concluded that the feature fusion worked because we had better results. So combining the different feature type boosted performance across the board, as we can see. Our final model, random forest, trained with all the features, achieved the best accuracy and most important, the best recall. That's important in the health area. So those are the results, and that's it.